All right, this is part 3 of chapter 8. Now we're going to discuss language. Language is a system of communication using sounds and symbols according to grammatical rules. It can be broken down into smaller parts, such as morphemes. Morphemes. This is the smallest language units that have meaning, including suffixes and prefixes. And there are phonemes, and these are the basic sounds of speech. They are the building blocks of language. Syntax and semantics are also involved. Syntax is the system of rules that govern how words are combined into phrases and how phrases are combined to make sentences. Semantics is the study of the system of meanings that underlie words, phrases, and sentences. Here's a handy graphic from the book to make more sense of this. Up at the top of the graphic you see the entire sentence. If you want to break it down to the phrases, if you want to break it down more down to words or morphemes, and down to the most basic unit of phonemes. The human vocal tract has the capacity to make many more sounds than any language uses. Languages differ from one another not only by the words that are used, but also by the number of phonemes and the patterns of morphemes. Speech is produced by moving air through the vocal cords, which is part of the larynx, and into the mouth. The lip and tongue movements then control the shape of the oral cavity and the flow of the air, resulting in particular sounds. When sound is recorded, you get a waveform. This is the waveform for the question, "What do you mean?" There are no spaces between the words, yet the brain normally can segment the waveform so that words can be understood. All right, now we're going to discuss language in the brain. There's a condition called aphasia. This is a language disorder that results in deficits in language comprehension and production. 40% of all strokes produce some aphasia, which can be temporary or permanent. When Broca's area is damaged, patients develop expressive aphasia, also called Broca's aphasia, which interrupts their ability to speak. If you remember, we covered Broca's area in an earlier chapter when we were talking about the split brain condition and why they couldn't speak the word of an object. Alright, Broca's area is not the only area involved in language in the brain. There's another area. It's called Wernicke's area. This is an area of the left hemisphere where the temporal and parietal lobes meet, and it is involved in speech comprehension. So Broca's area is involved in speech production. Wernicke's area is involved in speech comprehension. Receptive aphasia, or Wernicke's aphasia, occurs when patients have trouble understanding the meaning of words. Researchers have shown that a network of brain regions work together to facilitate language. All right, here's a graphic of the brain. As I stated earlier, Broca's area is important for speech production, and Wernicke's area is important for speech comprehension. They aren't too far from each other in the brain either. Extensive damage to the left hemisphere can cause global aphasia, where the person cannot produce or comprehend language. The right hemisphere also contributes to language in important ways, however, such as processing the rhythm of speech and interpreting what is said, especially understanding metaphors. A scientist named Benjamin Whorf in 1956 hypothesized that language reflects how people think. In linguistic relativity theory, the claim that language determines thought. The theory means that those without language are incapable of thought. All right, according to that scientist, Whorf, the Inuits may have developed many words for snow because different kinds of snow have played such an important role in their daily lives. People in warmer climates do not need such an intricate snow-related vocabulary. Backs up the idea that the words create the thinking. Language develops in an orderly way. As the brain develops, so does the ability to speak and form sentences. There's some variation in the rate at which language develops, but overall the stages of language development are remarkably similar across individuals. We learn language from our early interactions, usually with our mothers. From 0 to 60,000. From hearing differences between sounds immediately after birth and then learning the sounds of their own languages, young children go on to develop the ability to speak. From babbling as babies to employing a full vocabulary of about 60,000 words as adults, working very hard at it, without working very hard at it. In telegraphic speech, this is the tendency for toddlers to speak using rudimentary sentences that are missing words and grammatical markings but follow a logical syntax and convey a wealth of meaning. As children begin to use language in more sophisticated ways, one relatively rare but telling error they make is to over-apply new grammar rules as they learn them. When they learn that adding ed makes a verb past tense, they then add ed to every verb, including irregular verbs that do not follow that rule. Thus they may have said runned or holded, even though they meant to have said ran or held. There's an inborn capacity for language. Scientist B.F. Skinner in 1957 proposed that children learn language the same way a rat learns to press a lever to obtain food, through a system of operant reinforcement. However, language acquisition does not work this way. B.F. Skinner kind of oversimplified things. Another scientist, Noam Chomsky, in 1959 transformed the field of linguistics when he hypothesized that language must be governed by universal grammar. Surface structure in language is the sound and order of words, and deep structure in language is the implicit meaning of sentences. People automatically and unconsciously transform surface structure to deep structure. Language can also be acquired with the hands. Deaf babies exposed to signed languages from birth acquire these languages on an identical maturation timetable as hearing babies acquire spoken language. There are also social and cultural influences. Environment greatly influences a child's acquisition of language. The fact that you speak English rather than or in addition to Swahili is determined entirely by your environment. The term Creole describes a language that evolves over time from the mixing of existing languages. Animals can communicate too. Non-human animals have ways of communicating with each other, but no other animal uses language the way humans do. To test Chomsky's assertion that language is a uniquely human trait, researchers attempted to teach American Sign Language to chimpanzees. After years of teaching Nim the chimp, the team admitted that Chomsky might be right. Like all other language-trained chimps, Nem consistently failed to master key components of human language syntax. All right, language also involves reading, and it needs to be learned. When we look at letters grouped into words, we automatically derive meaning from these groupings, even if they are misspelled. This brings us to phonics. This is a method of teaching reading in English that focuses on the association between letters and their phonemes. Learning a small number of simple words that teach the sounds of letters across most words in the English language is how that works. All right, in this case, whole languages. This is a method of teaching reading in English that emphasizes learning the meanings of words and understanding how words are connected in sentences as opposed to just their basic sounds. The general idea behind whole language instruction is that children should learn to read the way they learn to talk. And to wrap this up, we're going to talk about dyslexia. You've probably come across this in culture. With dyslexia, learners struggle to figure out which symbols are letters, which letters are clumped into words, and which words go together to make meaningful sentences. People with dyslexia have trouble reading, spelling, and writing, even though they have normal levels of intelligence. Dyslexia may result from impaired sound and image processing, especially for words that rhyme. And that concludes part 3 of chapter 8.